There's 3 common use cases for this pattern. Use it when more than one object may handle a request and the handler isn't known beforehand. In other words, it should be ascertained automatically. This is made possible because with the chain of responsibility pattern you create a chain of linked handlers, and each handler gets a chance to process the request, but it doesn't have to. It can also simply pass it on. Another use case is when you want to issue a request to one of several objects, which are the handlers, without specifying the receiver explicitly. You don't know beforehand whether a handler is effectively going to receive the request. And lastly, when the set of objects that can handle a request should be specified dynamically. Translated to our handler example, all handlers and their order in the chain are specified at runtime. There's 3 main consequences to this pattern. One is reduced coupling. Our client does not know which handler will handle the request. The object that invokes the operation is decoupled from the one that handles the operation. Like that, we can work towards a single responsibility per class. The second consequence is added flexibility in assigning responsibilities to objects. We can control the order in which handlers are executed at runtime, and we can control which handlers are in the chain. And 3 is a disadvantage. Receipt isn't guaranteed. A request doesn't have an explicit receiver, so there is no guarantee that each handler will receive it or not, or that it will be handled at all. Let's have a look at the related patterns. The chain of responsibility pattern is often applied in conjunction with the composite pattern. Here, the parent of a leaf component can act as the successor. In other words, when a leaf component gets a request, it can pass it on to the parent, which can pass it on to its parent, and so on. That is a chain of responsibility. There's also a relation between the chain of responsibility and the command pattern. The handlers we implemented can be implemented as commands. When we look at some of the other patterns in this course, we find others that connect senders and receivers of requests. In that regard, chain of responsibility, command, mediator, and observer are all related. If you've watched the mediator or command modules, this slide should look familiar. Chain of responsibility, as we just learned, passes a request along a chain of receivers that can be defined at runtime until at least one handles it, or none at all. Command connects senders with receivers unidirectionally. For example, from a button that's pushed in the UI to the action that eventually gets executed. The mediator eliminates direct connections altogether. Communication runs through that mediator. And lastly, we've got the observer. That one allows receivers of requests to subscribe and unsubscribe to them at runtime. This pattern is coming up in the next module. But before we can get to that, let's have a look at the module summary. We looked into the chain of responsibility pattern in this module. Its intent is to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. It does that by chaining the receiving objects and passing the request along the chain until potentially an object handles it. When implementing it, make sure you provide an easy way to set the next handler. A good idea is to return the next handler, the successor, from that method to enable a fluent interface. Also, use generics to make the handler more, generic instead of tying it to a specific type. Up next, one of the related patterns, the observer.